are going to talk about taming scary production code that nobody wants to touch. And we have Mike Clement, who's a husband, father of 4, and currently a VP of engineering at Immersion. Mike believes we work best when we're working together, and that there are no best practices, only better and worse ones depending on the context. Some leading practices Mike is passionate about are test-driven development, pair and mob programming, user story mapping, domain-driven design, and open space technology. He's passionate about raising the bar on technical excellence in the software development community, and is founder and organizer of Software Crafters Atlanta, the Software Crafters Unconference, and the Lean Agile Atlanta Unconference. Find more about Mike on his blog, softwareontheside.com, and on Twitter at MD Clement. So without further ado, Mike, if you want to unmute yourself, I'm going to send you live.
Excellent.
There we go. Thanks a lot.
Okay, great. Hold on, that was not what I wanted to do. Man, it's
We'll get you back. It's okay.
Yeah. Okay. Which? Not that one.
That's a keyboard. There you go.
There we go. Not that one. That is. There we go. I think this is what we want. Hold on. Yes. Okay. Well, welcome everybody. This is obviously a little different than we probably normally do things like Code Camp. It's also for me the first live virtual presentation I've done for a conference setting. I've done a bunch of these in a work setting, which is a little more relaxed. It's also the end of the day. So hopefully, if you're here, you're engaged and interested in learning more about what we're going to talk about today. So like Stan said, the title of my talk is Taming Scary Production Code That Nobody Wants to Touch. I originally, several years ago, when I first started putting together this talk, I originally pitched it with a different title, which was Modernizing Legacy Code. The problem with that title is that what is legacy code? And there's not a whole lot of agreement on what legacy code is. And so so a couple different answers that I've gotten in the past, and our legacy code is code that we've gotten from someone else, right? It's something that we didn't write. The problem with that is often what it ends up being is legacy code is code we've gotten from past self. Past self wrote some code, and now we have to deal with it. I'm sure many of us have had the experience where we have gone and we've looked at some code and be like, who wrote this? We do a git blame, and then we find out it was ourselves from 6 months ago. So that's one definition. Wikipedia says it's a slang term for difficult to change code that we don't understand. So basically, legacy code ends up being this kind of derogatory term we use for anything that we don't really like. Michael Feathers, though, who wrote a book working effectively with legacy code about 15 plus years ago, he has the definition that its legacy code is simply code without tests. So one interesting bit about that is that I had the opportunity a couple years ago to sit down with Michael a little bit and ask him, now that it had been several years, like if he would update his definition. And he's like, well, here's what I would say now. Legacy code is when the people turn over faster than the code. So at the point where, so this kind of goes back to one of the original definitions where it's code that other people wrote. The thing is, he also sort of said it in the context of he will often use the definition of legacy code that will be most appropriate in the consulting gig that he's currently in, and in order to yield the results that he's looking for with the client he's working with. So for the context of today, we're going to stick with his original definition, which is that legacy code is simply code without tests. He goes on to make the further assertion that code without tests is bad code. So think about that for a second, right? Code without tests is bad code. And so is that true? What does that mean? So I would argue that code without tests is scary code. Now, that doesn't mean that it's necessarily code that I don't understand. But specifically that it is code that nobody wants to touch. So, and specifically, I'm talking about production code. Production code, legacy code usually refers to code, generally refers to code that is currently in production. It is code that is currently running somewhere, code that is currently giving value in some way. And presumably it is working to some degree, so, for some definition of working for the people that are currently using it. And, the thing is that you don't want to touch it because if it doesn't have tests specifically because of the thing we're going to talk about here in a second, right? Legacy code will often look like this, not literally, but metaphorically, in that there are wires all over places. There are switches that you don't know if they're working or not. Some are burnt out with that look like they may be connected to something, so you're not sure if that's even like important anymore. And so really, when we're talking about legacy code, we're talking about risk. We're talking about how much risk are we willing to take? Looking at this, right? This woman here, she's tightroping in some insane situation. But even then, she has decided to equip herself with a harness and has that harness attached to that rope that she's on. So again, it's all about these trade-offs in terms of risk that we're trying to take. So to mitigate risk, we want to ask 3 questions. 1, what are the changes that we have to make, right? So we don't really care about the quality of the legacy code. We don't really care if there's tests on this legacy code if nobody actually has to change it. So the risk comes when it's like, hey, we need to change this. We need to make an update, go in and make a change. And so the 3 questions again, what are the changes that we have to make, right? So we want to know what it is that the desired behavior afterwards is. 2, how are we going to know that when we've made those changes, we've actually done them correctly? And then 3rd, how will we know that we haven't broken anything? And that 3rd one is the trickiest one of them all, mostly because we can often make changes and we can know that we can reasonably assert that the new thing that we're doing works, but oftentimes in these systems, there's a lot of things going on. There's a lot of interdependent things going on. And so ensuring that they all continue to work is difficult and is really one of the key things that we're looking to do and one of the hardest problems. So if we're trying, so from the perspective of a company, right, that is going ahead and managing a product or trying to make trying to make money, presumably the situation that they're in continues to change, and therefore the software that is supporting that business, either via being a product or being some backend system, needs to continue to change. But the thing is, how often are you going to change it if it's risky to change it? And how much change can you afford if it's risky, right? Because again, the cost goes up, the harder it is to change and the more risk there is. So Along these lines, Bob Martin, often called Uncle Bob, Robert C. Martin, he posits this kind of, thought experiment, right? It's not necessarily something that we can take all the way to one extreme or the other, but do we want a system that is currently working to whatever requirements or needs are currently needing to be met, but would be very difficult to change, if not impossible, maybe not impossible, very difficult, very laborious to change? Or is it more important that the software system to be easy to change, but currently isn't quite working exactly how we would like it to? Now, we could debate whether or not we could go one way or the other, but Bob asserts that if you have that code, that software system that's easy to change, and again, him being a very experienced developer, if it's easy to change, he can change it, right? He can get it to do what we want it to do. And I would say that the easier it is to change, the more people would be able to do this. And also, like he says, keep it working as requirements change, right? As opposed to code that is currently working, but is not going to be able to adapt to future needs. Again, maybe in the moment, the working software is better, but if I cannot keep it working, then that's very, very unfortunate. If not risky, dangerous, not good for a company or a business or any sort of project. So this kind of goes to this core question of how do we keep software soft, right? We've had this idea that, it's at a certain point we had hardware and everything was embedded in the actual circuits, and then we have firmware where we can basically write code onto the chips, but then we have software where we can change it in a lot easier way, right? A lot more frequent way. It's if we didn't need our software to be soft, then at the end of a project when we were so-called code complete or whatever, when we're ready to ship, we would take our code and burn it into circuits and send that out. In fact, even 20 years ago, a lot of software was still delivered via, floppy disks and compact disks and different things that allowed you to ship software that, modified the functioning of a computer, but like once it was delivered, it was kind of in place. And some of us work in those situations still today, but most of us have the ability to be able to continue to modify that software over time. So we want to keep it soft. We want to keep it being able to be modified over time. So this leads us to the legacy code dilemma. And again, I'm kind of replacing the word legacy in many places with scary, but this is the legacy code dilemma. This is something that also comes from Michael Feathers. And so it has the two premises. One is that when we change code, we should have tests in place, right? Because we want to have confidence that whatever change we made, we're going to be able to detect it and that we're not going to make changes that we didn't intend to make. But often to put tests in place, we often have to change the code. And so many of us have probably been in situations where we've seen some code and be like, oh yeah, it'd really be great to have some unit tests here or some sort of tests in place. But like it's just not, it's not built for that. It's not designed for that. So so we can't do it. And so we just kind of put up with it. So as we go through, but again, that problem still exists. Like we're still going to change the code, but how about we make sure we take the time to change the code in a way that we have confidence so that we can go ahead and add the tests, and therefore instead of getting stuck like we often do where we feel like we're between this rock and hard place, we can leverage some positive reinforcing loops in terms of feedback. Be like, well, if we can make a little bit of change and get a little bit of test there, that will give us confidence to make more changes, and which will also enable us to add additional tests. But we have to kind of break out of that log jam that we're in at the beginning. And what we can do is we can do that via low risk changes through what Arlo Belshi coined as core refactorings. So if we look at refactoring, this is a term that gets used a lot in our industry now. I would say gets abused in some cases. Sometimes it's just like, well, we're going to talk about some of the mischaracterizations, but this is the definition that Martin Fowler, who wrote the book Refactoring, used. And he said it is a change made to the internal structure of software without changing its observable behavior. Now, that's a very strict definition, and not all the things that maybe we classify as refactorings end up not having any observable behavior. Sometimes they do speed things up or change some of the performance characteristics, but in general, what we're looking to say is I'm going to change the internal structure without changing the result, whether that's how it interacts with the outside world or with what kind of values it returns and displays to the user, those types of things. So, and again, this is a noun, right? A refactoring is a change that we're making. And so Arlo took that idea and said, well, out of the dozens of refactorings, individual refactorings that Martin cataloged, let's go ahead and pull out a couple of these. And how he did that is he kind of classified them into using the CRUD metaphor, which is often used for data, for database, right? Like we're going to be able to create things, we're going to be able to read things, update them, and delete them. And in this case, when we're talking about refactorings, we're talking about, oftentimes we're talking about naming. So when we create something, we're creating, we're basically giving it a name. Maybe we're taking a value and creating a local variable. We may be taking some code and extracting it to its own method, which again, we have to give it a name. And then update might be renaming that thing, right? It might be that we have to change based off our increased understanding of what's going on, what that name is. And then deleting would be inlining, which may or may not be familiar to, and I'll demo it in a second. But basically, it's taking something that's in a method, and if we're inlining the method and taking all those contents and just putting it where the method call is, and then therefore the method is no longer necessary, and we get rid of that name. So I'm going to go ahead now and do a little bit of live code. So in this particular case, we're just going to look at a couple of the things that I just talked about in terms of the refactorings, right? So excuse me. For example, if I come down here, we have r.days, and what I can do is I can introduce a variable. And if I do that, I can replace all 6 occurrences of it. And I can just say, this is the number of days, right? And this basically helps it to be a little bit more clear. Again, I've created this new thing. I've introduced a variable. If I'm like, oh, wait, I'm not in a language where underscores are something that we really do. So I'm going to go ahead and rename it to number of days using kind of Pascal casing. And I've renamed it, in this case, based off of my a change to my understanding of the idioms of the code I'm in. But it could also be that I just change it to days, right? Because I want to clarify it, or maybe days for this rental, right? Again, as my understanding of what the code is doing, I can update it by using that. On the other side, though, maybe I'm like, well, r.days is actually pretty expressive by itself, and I don't need this variable anymore. So I can inline the variable. And I'm just noticing now that you guys can't necessarily see all of my sorry, the little pop-ups, but we'll see how this goes. You may not be able to see them. Anyway, I inlined it back, so now it's all back in the same spot. And again, that's just, again, looking at we created a variable, we updated the variable, and we deleted the variable. So for context, I'm probably not going to stop because the whole delay thing seems to be I don't know, an issue. But if you put questions and stuff in Discord as we go, I'll go ahead and see if I can answer them. I do have it up here. If I don't get to them in the course of the actual presentation, I'll catch them at the end, or if we don't have time, I will answer them in Discord. So hopefully, again, pretty simple, pretty common things. But the big thing is that we were able to use our tools. So one of the reasons why these core refactorings are so useful at this point in the code without any tests is that they are basically the tooling is doing it for us, and so we have a high degree of confidence that they are doing the thing that we expect them to do. A lot of this has to do with having confidence in your tools, getting practice with your tools, and getting practice with these techniques. And the more you get familiar with these techniques, then the more confidence you have in them. So using your tools, hopefully whatever particular set of whatever tech stack you're in has tools that will allow you to do those core refactorings. I have not yet found a language that doesn't provide some form of tooling. Sometimes it'll cost a little money, but like JetBrains, which was what I was using there, I was using Writer. They have WebStorm, they have RubyMine, they have a Python-based one as well. Yeah, anyway, not that I am in any way paid by JetBrains, but I do appreciate their tooling. Okay, so use your tools, and there's a lot of free tools out there too for a lot of these core refactorings. If you're using VS Code, for many of the languages, many of these 6 core refactorings, those core refactorings, the create, update, and delete ones are included. Just depends on how confident you can be in them based off of how strongly typed your language is. Okay, so right with all of this, and I've stated this before, it's preserving existing behavior is one of the largest challenges in software development. Right? We don't want to accidentally change things that we didn't mean to change. Now, and we want to intentionally change the things that we want to change, but we can usually detect that because we're looking for it. It's preserving the existing behavior. And so what happens, I've been in code bases where, for example, when I worked in probably about 10 years ago, it was a suite of tools built for small government offices. So like cities, municipalities, some counties, but it was basically everything they needed to run their city from a software perspective. Mostly from an accounting perspective is where it started, but we also included things like pet licensing and cemetery management. But again, at the core of that were things like general ledger and accounts payable, accounts receivable, and payroll. And If there's anything that people are sensitive to not working, it is payroll. And the payroll module that we had was very awful in a lot of ways. Basically, the whole thing was in one huge method. I think we printed it off once and it was like 20 pages. And it was just a mess. And there was one guy who was kind of responsible for it, and he kind of knew it well enough that he could go in and make changes. But for anybody else, they didn't really want to go make changes in there, right? They would have to, again, put on that metaphorical hazmat suit if we did have to make changes, because it was just like very difficult to understand. And I wish I had some of the tools that I have now, but if I had the tools that I have now, I think I would have been a lot more confident. On the flip side, though, it was pretty good job security for him, at least in the short term. Unfortunately, for him, eventually a couple of us were able to get in there and to make improvements to it to the point where he wasn't as secure. But again, it's, but he had to kind of grow in order to be like, oh, well, I can't just be the guy who knows this one thing. But again, it's that idea of like, it's just feels very dangerous to go in there, very scary. And sometimes it feels like this, that we're just looking into the abyss. So the common technique that people use is edit and pray. I do not recommend this technique. Usually what it means is that you go ahead and you make some changes, you kind of poke at it, you kind of like, oh, look, it looks like it's doing the thing I expected to do, great. It looks like all of the values look like they're right, so great. Great, let's go ahead and deploy it to production, right? Unfortunately, this often leads to this, where we're just like drowning. It's not, it doesn't work. A related similar path is to do the working with care. Basically, I'm going to just be really careful, and then it's just all going to be all right. Unfortunately, these people look like they're being careful. Still, yeah, it's just still difficult. So ideally, in this case, and maybe at some point when we have a lot of confidence in our system, we can go to this point. But to start out, I want to do cover and modify. And what this idea is that we're going to put nets in place. We're going to have safety harnesses, and it's going to make us feel secure as we move forward. So again, what that means, that cover part, so obviously the modify part is to make the changes that we want to make, but we want to preserve the existing behavior. And so in order to do that, we use a technique called characterization tests. And characterization is describing something. Like, we want a description of the features. That doesn't mean that we want to know what it's supposed to do. It doesn't mean that we want to know that it's doing the thing that it's supposed to do. In this particular case, right, characterization tests are only helping us to understand what it currently does. Now, I emphasize this because what this is doing is helping us guard against unintended changes. Right? So again, we're making sure to characterize the actual behavior, the current actual behavior of this software, not what it's supposed to do, what the actual behavior is currently. And again, it might sound like I belabor this point, but oftentimes we think of tests as helping us to ensure that it's doing the right thing. In this particular case, these characterization tests, they're helping us to maintain the current actual behavior. Now that, so it's like putting the code in a vise so that everything stays still except for the thing that we want to change when we're ready to change it. But that means we have to have everything locked down well. Another metaphor might be, tying a boat up, right? We don't want the boat to float away. So again, I'm going to belabor this point a little bit more. We're not checking for correctness. We're checking for existing behavior. And the benefit that this has is that we don't actually have to understand the code. We don't have to understand the code. Now, we might have to understand a little bit, right? We have to understand how to code, but we don't necessarily have to understand everything that is going on in there. So what I'm going to do is I'm going to transition back to writer here, and we're going to take a look at a library called approval tests, and I'll be using that in combination with the NUnit to do this golden master characterization tests. So again, in that same place that I worked with the large payroll method, when I first got there, I was like, I opened up the solution and I saw a bunch of projects and I saw a bunch of test projects, and I was like, awesome, this is great. Like, I'm going to go ahead and take a look at these. And I ran the build and I'm like, okay, this all builds, that's great. And I go in and I try to run some of the tests. I'm like, and then I get a failed build. I'm like, what is going on? Well, in this particular case, there were a bunch of test projects that had been started at a certain point, but they did not continue to get maintained to the point where they were slowing people down so much that they just decided to not actually delete them, but just disable them from the build and no longer run them. And so the ones that I was able to get to build, they usually didn't pass, or most of them didn't pass, and many of them didn't even build because they hadn't been kept up to date with the current changes in the code. So in that spirit, for this exercise, I have all the tests. I have a test project. I have all the tests, and this is probably actually even a better situation than what I described. I actually just don't even have any tests, right? Some frameworks now will actually create test projects or test harness, I guess, or just like scaffolding for tests, but they don't actually do anything or nothing particularly useful. And so, sometimes you just have an empty test. But in this case, we're just going to use this in order to get started. So I have already installed the appropriate NuGet packages for NUnit and for approval tests. And so I've gone ahead and imported those. So it's approval test.reporters and NUnit framework, and I've just set this up as a fixture. This use reporter, what this does is when there's a problem with one of the tests, it needs to know how to report it to you as the user. And in this case, we're using the diff reporter, and I'll show what that means here in a minute. We have all the tests. And so what we're just going to do is we're going to start by just writing a test. And how often do this? I'll just call this test 1. I don't know what it's called. Again, in the spirit of the whole CRUD thing, I'm just going to create a test and then rename it later once I have more information. So what I'm going to do is approvals.verify. And so again, in this idea of I don't actually need to know what the code does, I am just going to simply run the code and then approve the result. So so again, we have that rental info class that we were looking at a little bit before, and there's this statement method, and that's what we're going to test. So we're going to do new rental info dot statement, and that's it. So if you've written any tests before, you're probably like, there's something missing, and you are right. Oftentimes, or usually, in any good test, right, we have some sort of expectation, whether that's embedded in the, like, we do like assert is true, we expect it to be true. Or if we do an assert equals and we say, here's the thing that we're running, and then here's what our expected value is. And if you'll notice here, there is no expectation that is being set. But I'm going to go ahead and run this test. And like I said, so it's failing. And as I pointed out, right, I'm using a diff reporter. So I'm going to switch over to tortoise merge. And that's not working. Let's see if I can fix that really quick. There we go. So we have tortoise merge. And if you notice here, what approval test is doing is it said, it ran that code, that returned a string, and so this is what it received. It received this, what looks like a statement about the rental record. And what this is saying is that, hey, I looked for something based off of the test fixture and the test name, and I looked for something approved, and I didn't find anything. Again, it's this idea of like we're approving it. So what I can do is I can just say, you know what? Yeah, we're just going to approve what it does. Again, we're not even really going to look at it. It's just like this is what it does because we're just doing characterization tests at this point. So I'm going to go ahead and save it. I'm going to come back here. Okay, so I approved that result. I'm going to run it again. And it passed. Okay, awesome. Well, let's run it again. And it passed. And we can see here, right? We can see here in our IDE, here is where we have copied our approved result, right? It's basically just saved the approved result as a text file. If I was doing this in our code, then I would then commit that as part of my Git repository. So I have this thing that's approved. I'm gonna run this one more time. Maybe one more time. So at some point, this is going to fail. I'll run it one more time. Keep running it. Okay, well, this is how random things work when you set it to be one way or the other. Oh, there it goes. Okay, so if we pull this up. Okay, so we have this, and we can see here that because it pulled up again using the diff reporter, it's reporting, hey, this time this first line was the same. The second line, that's a different movie with a different value, and that's a different movie with a different value, and that is a different amount owed. You still get 2 frequent renter points, but everything here in the middle is different, not what I expected. So this is not a great result, right? We want our tests to be deterministic. So what I'm going to do is we're going to slide back over to the slide. So now that we have that in place, right, we have a test that is testing the statement. You know, it is not a great test yet because there's obviously something going on in there that is potentially giving us different data based off of which time we run it, which will often be the case. And so what this leads us to is this idea of seams, right? Usually there's some part of our code where maybe we're getting data from a database, or we're doing something and then sending data somewhere and then we're getting it back, whatever those are, right? So a seam is a place where we can alter the behavior of the program without editing, not editing the program, right? So the very, you know, obviously there's places, you know, if we can pass parameters or arguments into like a command line program, that's a place where there's a seam. But within the context of our program, the most common one is a method boundary. right? Because we can pass parameters in and we can get data back out. And so if we come back here in the code, we can see that our statement doesn't take any parameters. So that's a little bit disturbing, right? That is not an effective seam. It's probably not the most effective place to test. If we go in here, we can see that the first thing that we're doing here is getting the current customer. And we get the current customer, like what is the current customer? And so to simulate this, and again, this is for demonstration purposes, and why it took a couple times for me to get a different result, is that I'm just doing next double and seeing if it's so approximately half the time it's getting one versus the other. And you notice the customer name is the same, which we saw, but the list of movies, here we have 1 and 2, and here we have 3 and 4. And so given that, that's going to cause problems. So what we want to do is, I come back over here to the slides. We want to use a method called peeling. So in this case, if we have code that is causing some problem, usually because it's not deterministic, it's hitting a database, it's getting input from the user, whatever that is, we want to go ahead and peel that off the outside so that this code here is code that we can easily test in a deterministic way. So we're going to go ahead and peel this off. So it's very simple. Again, using our core refactorings. What we're going to do is we're just going to say, hey, this get current customer is the thing that's causing us problems. So we're just going to take the rest of this method all the way down to the result. And using my tool, I'm going to go ahead and extract a method. Okay, it is not showing that, but it's giving me a dialog that I can extract the method. I'm just going to call it statement. It's going to pass in the customer, and you'll be able to see it here in a second. Okay, so our statement method that we've had before, right, didn't take any parameters. Now it's going to get the current customer, and then it is going to pass that into statement. And this is our new statement that does everything that that original statement used to do. We just extracted a method, which again is one of our core refactorings. And now what we can do is we can go into our code, and instead of, here I will. Again, you probably cannot do this particular part of it this easily, but I can just take one of these customers, these customer objects, and pass that in. What I'm going to do. Okay, so I now have a new customer, and I'm passing into the statement. And so it's always going to get the right customer for me, which is what we want to do. So if I run it now, pretty sure I approved for this one. Yep. So now this is going to reliably be able to pass, and then I can create a second test with that other customer if those are kind of the two characteristic, or like two customers. We're not, again, right now, for the purposes of today, we're not trying to get complete test coverage. I do have another presentation where we talk more about that. But in this particular case, we're just trying to slice off that outside so that we can then add a test that is deterministic. So we're peeling it. Okay, so we did a little peeling. So the other problem is that sometimes our code has like a database call in the middle of it. In this particular case, we had it conveniently at the beginning, which was nice. But sometimes it's in the middle. And so what we want to do is be able to pass in an object that will do the thing so that we don't have to have that thing happen in line. We often talk about dependency injection, but we talk about it at the application layer level, but sometimes we want to inject the dependency at the level of the method as well. So this method is called slicing, right? We peel the outside and then we got to slice out the middle. We'll do that really quick. So in this particular case, right, we have in the middle where we have to go and look up the movie. Now, for our particular case, this movie database is probably pretty stable. But if it was real code, because I mean it's pretty stable in that it's just a dictionary that we're looking up. But this is just sort of, let's just say this is a proxy for an actual database with real data in it. And you know, if we're hitting like a staging database or even a local database, we don't have to be dependent upon the state of the database for our test to be able to run. It just makes it a lot messier and a lot more difficult. Additionally, we can't easily, if we were to maybe, in this case, if we see there's like a new type of movie or a new movie we want to test, then it becomes more difficult to do that because then we have to actually put it in the database as opposed to, again, injecting the dependency. So we have this lookup movie. And you can, again, imagine that this was like doing a database connection and a SQL query and whatever. So what we're going to do is, in this particular case, we're going to, again, do a series of fairly simple core refactorings. We're going to do a slightly more complex one here where we're going to extract a class. So we're going to take this lookup movie, we're going to extract the class, we're going to call it movie.db. I'm going to make sure that this is a public method now. I'm going to move it over. So what that just did is it took our movie database, our lookup movie. It created a new movie.db class, and it took that lookup movie method and moved it over there. And now our rental info news up a movie.db. And then uses that when it's time to look up the movie. Now this gives us, you know, the ability to pass in the class, and depending upon what we're doing, we could actually pass in a function if that was what we wanted instead. But this one, just for the purposes of today, we're going to say that it's a class. Maybe you're using the repository pattern or something like that. But instead of newing it up in the thing, we're going to want to have it injected. So in this particular case, what I'm going to do is do another introduce parameter, and what it's going to do is it's fine. So I've introduced the parameter movie.db, which has replaced the movie.db, the underscore movie.db, and so now at the place where this is being called right here. Right, sorry. We're using this one, which is maybe fine for now. But then in our tests, it's like, oh, I don't even know what that is. So what we can do is, I forgot one step. What we want to do is also extract an interface. We're just going to call it iMovieDB. So we'll look up movie. We'll change the type here to iMovieDB. And then in my test, I can just say, well, I could just say a new movie DB if I wanted. but I could also easily create an additional movie DB that also inherited from that interface that was a test movie DB that, again, gave me the exact movies that I wanted for the context, for the particular test that I wanted to run. So the important thing, though, is that we sliced out that dependency from the middle. And so now we have increased the ability for us to control this code and control the code going down different paths, and which will allow us to, use our testing framework to be able to get better coverage, again, in an effort to put the code in the vice to characterize the tests, characterize the code using our tests, which, again, is what our goal is right now. So again, using a combination of characterization tests and our core refactorings, we're able to get increasing test coverage on this code, be able to make small incremental changes to the code that will allow us to introduce themes that will allow us to make this code a little less scary. And again, if we define legacy code as code without tests, it's scary production code that nobody wants to touch. But with these tools, it's actually interesting where it's actually becomes fun to work with this code. And so hopefully I've changed it for you that it's not nobody wants to touch, but that you want to touch this code. You want to go in because it's not scary. It's not higher risk because you have the tools of using these 6 core refactorings and approval tests to be able to quickly get your code in a place where it is under test and happy and a better place to work. A few years ago at Explore DDD, Jessica Carrick talked about how when she hears legacy code, she hears useful. We talk about legacy systems as if they're a bad thing, but legacy systems are systems that work. They are systems that are adding value to somebody's life. And so getting the opportunity to work on those is actually a privilege in that we get to help to continue to add value to whatever situation we're in, whether via a product or via an internal system that's helping to support internal processes to a company. And so this also exhibits this other thing that I have come to very much internalize. As Kent Beck said, for each desired change, make the change easy. Warning, this may be hard, then make the easy change. And I've just done like the very little bit first part of that. There are additional things that we could do, but using those core refactorings to make it easier to test, making those small refactoring changes, making those desired changes that will make it easier to test, make it, and therefore easier to work with. So with that, thank you. I haven't seen any questions come in via Discord. I don't know, Stan, if you've seen any questions elsewhere, but here are some resources. I will post a link to these slides in Discord. But these are the books and the techniques that I referenced. This is a little bit about me. You can actually go to blog.softwareontheside.com and find this and other slide decks, as well as some videos of some of the presentations I've given in the past. And I'd love to connect with you on LinkedIn. If you're interested, I do run the Software Crafters Atlanta group, and we do meet online right now due to the global pandemic, and we are would love to have you join us, especially since y'all are in the same time zone, in the Eastern time zone. So if you can find us on Meetup, that'd be great. We do coding exercises, kind of like what we did tonight, but actually interactive, not just demoing. So thank you, everybody. And have a great rest of your day. I guess we're at the end of the day. Awesome. I can't hear you, Stan. I don't know if you're muted.
There is one question, if you want to field it real quick. Can you hear me now?
Yeah.
Would it be worth adding a test project to the old web form project?
To a web forms project? I would say yes. One of the first, again, thinking about these seams, right? A lot of times the web forms, you're going to have to introduce seams, which would mean taking as much of the functionality, assuming that you're in a web forms project where there's a bunch of code behind, like trying to push as much of the functionality out of the code behind into potentially another project, and then using that. Additionally, I have not personally used it, but approval tests for C# for .NET does have some functionality that helps to test web forms, basically at the HTML level, where you can basically say, hey, test this controller, and it will do all the things, and then it will get the HTML back that would be served to the client, and then saves it into that text file like we showed, and then would again allow you to at least start from there. That's a lot more difficult because then you still don't have like a lot of the control that you might want to have in order to test effectively, but it might be a good place to start. At least some scaffolding to kind of hold things in place while you maybe do some additional work, creating seams further down the code stack. So hopefully that was.
Great. I'm not seeing any other questions, so I'm guessing that answered their question. Thank you so much. I think this was incredibly useful information, and something that I think a lot of us could really put to use immediately. So really thankful for your time today and participating in the first in-person Nova Code Camp. I'm not sure if this is the first virtual Code Camp, but I'm sure there will be others. Want to just thank everybody for that was here for the whole day. I want to thank Mike, and I'm going to let you get off camera because you've been on camera for an hour now, so you probably need a chance to sit back and relax and take a deep breath. We're coming up on 5 o'clock, so 9 to 5 with an hour for lunch, and that was a lot of information. So we're not doing a group thing, so I don't think there's any reason to head over to the etc. channel, but these will all be spliced up, and pending speaker approval, we're going to put them out onto YouTube or somewhere for people to be able to access them, which is a benefit that we don't usually have when we do this in person. If people wouldn't mind just posting before you go, I see we still have quite a few people, just post in the Discord text data track where you're from. I'm just curious, how far this reached and how many people were local and how many people were out of town or out of country even. I know we had a speaker from England, so we certainly have had a more international feel to this than we usually do. Usually the furthest we get is somebody driving up from Virginia Beach. So again, thanks to all our speakers. We couldn't have done this without you guys, and we're very thankful. I think, based on what we know, I think we'll be doing this at least the next time, maybe
maybe we'll do it sometime over the winter, and maybe in the spring we can actually all get together again. I would really like that. I miss making coffee for everybody and even cleaning it up. So it's 5. You're free to go, and thanks again to everyone. Bye-bye.